Here we have another reaction that I am going to use the algebraic method to balance. Once again, we start out by assigning dummy coefficients A, B, C, D, and E to every species in the reaction, be they reactants or products. The next step is to develop our individual equations using each element: carbon, hydrogen, nitrogen, and oxygen. We'll take advantage of what we know from the stoichiometry of the individual molecules, as well as what we know about how the coefficients work, and use that to develop our equations. However many of these molecules I have, each one will give me one carbon. So that gives me A equals C. For the hydrogens, I will have 5 hydrogens per molecule, and I have 2 hydrogens, so 5A equals 2E. For nitrogen, I pick up 1 nitrogen and 2 over here, so A equals 2D. And for oxygen, I have that 2B equals 2C plus E. At this point, I have made no decisions whatsoever, but I'm about to have to make one. And that then is the first thinking step. I have to look at the equations I have and make a determination that is it possible for me to use a value for one of the coefficients to allow me to determine the values for all of the other coefficients. And so in this case, I recognize that if I pick a value for D, this gives me A, which will in turn give me C and E. So making that one choice, I could have chosen A, and it would have given me C, E, and D. But what's important to note is that once I have the values for C and E, I can determine a value for B and get everything I need. So in this case, I'm going to say let D equal 1. If D is equal to 1, then A equals 2 times 1, so A equals 2. A and C are also equal to each other. And I have to do a little bit of math. 5A equals 2E. This is from the hydrogen equation. And so 5 times 2 is 10. If I divide through by 2, then I get a value of 5 for E. And finally, because I have values for C and E, I can determine a value for B. So using the oxygen equation, 2B equals 2C plus E. So 2 times 2 is 4. 4 plus 5 is 9. If 2B equals 9, then B equals 9 over 2. Now in this case we find values using the algebraic method, but they're not all whole numbers. In this case we want to get rid of all of our fractions, and in order to do that I will have to multiply everything by 2. And by making that change, that will give me whole number ratios. So A equals 4, B equals 9, C equals 4, D equals 2, and E equals 10. It is a straightforward exercise to substitute these values into the equation and verify that we have achieved proper balance for the number of carbons, hydrogens, nitrogens, and oxygens on both sides of the chemical reaction.